All right, so look at the example 4 on page 142. Okay, it goes on to 143 as well. Okay, so you have a problem. Okay, this is a finding the model and solving it. So grain is leaking through a hole in a storage bin at a constant rate of 8 cubic inches per minute. The grain forms a cone-shaped pile on the ground below. As it grows, the height of the cone always remains equal to its radius. If the cone is 1 foot tall now, how tall will it be in 1 hour? Alright, so reading the problem carefully, we realize that the formula for the volume of the cone is needed. From memory or by looking it up, we get the formula is V is equal to 1/3 pi r squared h. Okay. A careful reading also reveals that the height and the radius are always equal. So we can get volume directly as a function of height to be V is equal to 1/3 pi h cubed. So if h is equal to 12 inches, the volume is pi over 3 times 12 cubed, or 576 pi inches cubed. Okay, 1 hour later, the volume will have grown by 60 minutes at 8 inches cubed per minute, so 480 inches cubed. The total volume of the pile at that point will be 576 pi plus 480. And so then use the volume formula to solve for h, and getting the height is 12.98 inches. Okay. Alright, and then let's look at the one right below it, and then we'll go look at some problems. Okay. How many rotations does a 15-inch radius tire make per second on a sport utility vehicle traveling 70 miles an hour? What? I just read the example out of the book. Well, I'm not expecting you to know. I'm just letting you see kind of what kind of problems we're looking at, and then we'll actually do some. Alright, example 5. Okay, we already read the problem. It is the perimeter of the tire that comes in contact with the road, so we first have to find the circumference of the tire, which hopefully you remember is 2 pi r. So putting in the radius, you get 30 pi. Now, one rotation is equal to 30 pi, okay? But we're going to have another conversion to figure this out completely. So we have to convert miles per hour to rotations per second, and we have to do this with conversion factors, okay? So you're going to have to get rid of your minutes and getting it down to seconds, okay, using that setup, okay, like you've probably done in your science classes with Miss Marshall. And then you need to convert miles to rotations, okay? What we have is that a rotation is 30 pi inches, okay? That's what we got from the conversion of the circumference there. So that's how we get down to rotations per second, and then multiplying and dividing everything that is there, okay? So that's just a quick rundown of what these kind of problems are looking at. So we're going to go and try to find some like it and practice a couple. And then we'll wrap this section up tomorrow, and you'll have test Friday. So, let's start with 16. One leg of a right triangle is twice as long as the other. Write the length of the hypotenuse as a function of the length of the shorter leg. Okay. So we have a right triangle, okay, with a leg that is twice as long as the other. So basically, something like this. Ooh, got it connected there. Might be a little longer than twice, but. So let's just say if that's the height, we can call it whatever. This is 2h. Okay, it's twice the length. I guess I could call them L for length, but write the length of the hypotenuse as a function of the length of the shorter leg. So when I do the Pythagorean theorem, it would be this squared plus this squared is equal to this squared. I'm going to call this A. So then this gives me what? Hold on a second. I think I have that written wrong. I'm confused because I ended up using H. Hold on. So this is, make sure I'm reading the problem correctly. One leg of the right triangle is twice as long as the other. Write the length of the hypotenuse. So A squared plus B squared is equal to C squared. So I have these two. So the square root of A squared plus B squared is equal to C. So I would need to plug this stuff in. So that would be H squared plus 2H squared is equal to C. Well, yeah, I guess I could have written it that way. There. So then what do I get? Well, 5H. Huh? So this is H squared and H squared, and then this is 2 squared, and then just 1. So that gives me 5H squared. Then I can pull an H out. So H square root of 5 is equal to C. So that would be my hypotenuse, is H square root of 5. Alright, 18. Alright, a square inscribed in a circle, or a square is inscribed in a circle. Write the area of the square as a function of the radius. So basically, I've got a circle. I've got a square inside of it. Okay. I know that my radius is from the middle to this point of the square here. Huh? Alright, so some things that we know here. Okay. Radius is half the diagonal of a square. S is the side of the square. Or radius of the circle. Or wait, sorry. Wait. Yeah, that, hold on. Not that. Apparently I can't read. Okay. So then, so we have S there. Okay, so I have basically a right triangle here. Okay, meaning I can use the Pythagorean theorem. So r squared plus r squared is equal to s squared. So 2r squared, square root of that is equal to s. Are we done? What else do we need to do? Square root of 2r. Am I done now? No. I want to know the area of the square. If I just had the square, what would the area be? S squared. So I'm going to replace this with this stuff here. So it's going to be, yep. So this is 2r squared. Alright, Alright, I'm going to add on 2 problems to what you had the other day, and you can start working on them. Tomorrow we'll do some more, but we don't really have time to do like another whole word problem before class is over. No. Everything will all be due Friday at once, which is also the day of your test. So, I mean, tomorrow you should have time to work on them in class, though. But I would get going on some of them if you haven't already. I'm just adding on 15 to what you already had, actually. Try not to give you guys the super hard ones.